Dear student, welcome to Sri Shivaji College of Arts, Commerce and Science, Akola. Virtually, I am Kanchan Vishramji Kumbhalkar, Assistant Professor, Department of Chemistry, and I am here to discuss you some points of Unit 6 of Gaseous State. So this is the overall syllabus of a gaseous state, and the B part, that is phase rule. Now this is my third lecture on this unit. So let's start the lecture number 3 of gaseous state. So the today's first topic is the collision diameter. What is meant by collision diameter? A molecule can approach other molecule up to a certain point. When this point is reached, the two molecules begin to repel each other due to their electron clouds, and reversal of direction of motion takes place. The distance between the centers of the two molecules when they have reached the point of cost approach is called collision diameter. It is denoted by that of the sigma. Generally, the value of collision diameter sigma is twice the radius of molecule, that is sigma is equal to 2r. Now basically molecular collision diameter होता क्या है? What is meant by collision diameter? एक मॉलिक्यूल दूसरे मॉलिक्यूल के तरफ अप्रोच होगा, बट वो एक लिमिट के बाद वो अप्रोच हो नहीं सकता बिकॉज दे हैविंग द इलेक्ट्रॉन, बोथ द मॉलिक्यूल्स हैविंग द इलेक्ट्रॉन. और जब वो इतने नज़दीक आ जाता है कि देयर इज़ अ इलेक्ट्रॉन इलेक्ट्रॉन रिपल्शन, एंड ड्यू टू विच व्हाट हैपन, द बैकवर्ड पाथ हैज़ बीन गेट मीन्स दे गेट रिपेल टू ईच अदर. इसी वजह से उनका जो मोशन का डायरेक्शन है वो रिवर्स हो जाता है. इसीलिए द मिनिमम डिस्टेंस, द डिस्टेंस बिटवीन द टू सेंटर्स of molecules when they have reached the particular point जहाँ से आगे वो अप्रोच नहीं कर पाएंगे, that minimum distance is declared as a collision diameter, और उसे सिग्मा की तरह आप डिनोट कर सकते हो. एंड इट इज़ इन जनरल वे दैट जो मॉलिक्यूल अगर सेम टाइप के मॉलिक्यूल्स हैं उनका जो रेडियस रहेगा उसका डबल इज़ नथिंग बट अ molecular collision diameter. So hence the radius of molecule, if you get twice it, अगर उसे डबल किया जाए तो that distance is nothing but a collision diameter, means sigma is equal to 2r. So this is all about the collision diameter of a molecule. Next point is the collision number or a frequency. एक मिनट में 1 cc अगर आप गैस ले रहे हो, एक सिलेंडर ले लिया, उसमें 1 cc ऑफ गैस भर दिए, और एक सेकेंड में कितने बार कोलिजन हो रहा है, दैट कोलिजन इज डिनोटेड बाय दैट ऑफ द कोलिजन नंबर, एंड इट इज़ डिनोटेड बाय कैपिटल Z. कोलिजन नंबर और फ्रीक्वेंसी मीन्स it is the number of collisions between the molecules in 1 cc of gas per second. It is denoted by capital Z. The molecules are constantly moving and different types of collision can take place. Two molecules may have a head-on collision or a grazing collision or a collision at any angle, as all angles of collision are possible from zero collision. So hence relative velocity will be under root of 2v, where v is the average velocity of the molecule, while calculating collision frequency, that is Z, is relative velocity of the molecule is to be considered in place of its average velocity. So this is considered as the collision number. मतलब एक पर्टिकुलर एरिया में अगर एक पर्टिकुलर क्वांटिटी ऑफ मटेरियल अगर आपने फिल कर लिया and then there is a movement takes place, then that collision gives a collision number. मतलब 1 सेकेंड में कितने कोलिजन होंगे दैट विल बी डिक्लेयर्ड एज अ कोलिजन नंबर. और इसमें और एक चीज़ इम्पॉर्टेंट है, देर आर द वेरियस काइंड्स ऑफ ओरिएंटेशन ऑफ कोलिजन. मतलब जो डायग्राम में ए डायग्राम दिखाई है, देर इज़ अ हेड टू हेड कोलिजन और हेड ऑन कोलिजन. सेकेंड जो बी डायग्राम है दैट डिक्लेयर्ड इट इज़ अ ग्रेजिंग कोलिजन, मतलब साइड बाय साइड कोलिजन हो रहा है. एंड एट द लास्ट जो सी टाइप की डायग्राम दिखाई गई है यहाँ पे, दैट विल डिक्लेयर्ड एज अ कोलिजन एट एनी एंगल. मतलब देर इज़ नो एनी प्रेडिक्शन, उनका डायरेक्शन जो है वो प्रेडिक्टेड नहीं है. जो एरो दिखाया गया है दैट विल बी डिक्लेयर्ड एज अ कोलिजन डायरेक्शन. So this is the about some point of collision. So basically there are three types of collision as previously stated. First one is the head on collision, जहाँ पे उसकी relative velocity रहेगी 2v और उसका angle रहेगा 180. There is a face to face collision. दूसरी रहेगी grazing collision where the angle is 0, means they are moving in parallel direction. They are moving in a parallel direction and the relative velocity is equal to 0 for that. And at the last collision at any angle or at a 90 degree, so the relative velocity will be under root 2v. So there are the basically three different kinds of collision patterns on the basis of angle of collision. After that, first we shall calculate the number of collision made by a particular molecule which alone is supposed to move when other are at rest. The collision will take place whenever the distance between the centers of the molecules is less than a molecular diameter. During 1 second, the molecule which moves with relative velocity under root 2v sweeps out a coding volume of space under root 2v pi sigma square. It will collide with any other molecules whose center lie within this volume shown in the figure. So this is the molecular collision explanation. So in this case there are the various kinds of velocities has been declared on the basis of collision angle. If under the given condition of temperature and pressure, number of molecules in 1 cc of a gas in N, the number of molecules which would collide with this particular molecule would be under root 2v pi sigma square N. So when we are considering only one molecule, if वहाँ पे अगर सिर्फ एक ही molecule है, one mole of molecule is there, then its particular velocity can be declared as, its condition is under root 2v pi sigma square. But for n numbers, it will becomes under root 2v pi sigma square n. This is the collision rate for one moving molecule. That is the number of collisions suffered by one molecule per second. When all molecules are considered to move, we have to multiply by n, and the number of colliding molecules per second per cc become under root 2v pi sigma square n square. But two molecules are required to produce each collision. The related with that, to quantity by 2 in order to get actual number of collisions per cc per second can be considered as the frequency. The number of collision per cc per second, that is known as the collision frequency, which is indicated by the z, is given by z is equal to under root 2v pi sigma square n square upon 2. By cancelling the 2 and under root 2, we get the finalized value, that is v pi sigma square n square upon under root 2. This is the value for collision frequency when you are considering the single molecule. So that will be declared as a z is equal to v pi sigma square n square upon under root 2. Now v is given as 8 under root of 8 RT upon pi m. So ये पहले ही निकाला है पहले जो सेकेंड लेक्चर में हमने v का वैल्यूज़ डिस्कस किए थे. सो द v इज़ गिवन हियर, that is a under root of 8 RT upon pi m. So put the value of v in previous equation of z. So z become z is equal to pi sigma square n square into under root of 8 RT upon pi m upon under root 2. Now simplifying this equation, we finally get 2 sigma square n square under root of pi RT upon capital M. In a gas, all molecules are identical, so the above equation gives the collision frequency between the similar molecules. In a mixture of two gases, colliding molecules are different, and in such case, the collision frequency Z is given by the equation. That equation is Z is equal to 1 by 4 NaNb in bracket sigma A plus sigma B whole square into 8 pi RT in bracket Ma plus Mb in bracket complete Ma Mb to the power half, means it's all in a under root, where Na and Nb are number of molecules of two gases per cc. Sigma A and sigma B are the molecules diameter, and Ma and Mb are molecular weight of the two gases. Next point is mean free path. The distance traveled by a molecule before colliding with another molecule is called free path. The average of all such free paths in a given volume of a gas is called the mean free path. Thus, the average distance traveled by a molecule of a gas between two successive collisions is called as mean free path. If v is the average velocity of a molecule and x is the number of collisions suffered by the molecule per second, the mean free path L is equal to v by x. We have seen that the number of collisions suffered by a molecule per second is equal to under root 2 capital V pi sigma square n square. So L can be written as V upon under root 2 V pi sigma square n, which can be clear as 1 upon under root 2 V pi sigma square n. It is possible to calculate the mean free path of a gas from its viscosity by using the expression L is equal to eta into 3 upon Pd, where eta is the coefficient of viscosity, P is the pressure in dynes, and D is density of a gas in gram per cc. So this is all about the various definition, that is collision diameter, then collision frequency or collision number, and the last one is the mean free path. So take care. Thank you very much for this lecture.